All right. Welcome, everybody, to Standing for Truth. My name is Donnie Badinsky, and I am thrilled to be here with creation speaker Brian Lauer for a program answering the important question, what is the true origin of the Grand Canyon? Now, many of you might be wondering or asking yourselves, wasn't this supposed to be a debate with Jackson Rowe? And yes, it was, but for personal reasons, Jackson was forced to back out of tonight's debate. But that doesn't mean we can't still have some fun here tonight and give you guys an engaging, information-packed, thought-provoking program. And so what we are going to be doing here with Brian, and I'm excited, we are going to be giving the floor to Brian for an in-depth presentation answering this question, what is the true origin of the Grand Canyon? In a debate, you're kind of limited to a shorter opening statement where in many ways you have to condense all this information. But now we have the great opportunity to take our time exploring this topic, but also having an interactive program. So for those in the audience who might disagree with the model or the arguments that Brian Lauer here is putting forth, you can do a couple things. You can send in through text some challenges, objections, or comments that we will have Brian address live here. Or if you are an evolutionist who wants to engage in some discussion and debate, impromptu discussion in a cordial, professional manner, then I will put the StreamYard link and take some call-ins after Brian's initial presentation. And so with that, Brian, not your first time here on Standing for Truth. I always look forward to having you on. And so, Brian, I know you've been busy, brother. As a matter of fact, you just got back from a trip to the Grand Canyon. And so tell us, how have you been?
Oh man, it was so much fun. It was through Creation Today. That's Eric Hovind's ministry. And it was just a blast. It was so relaxing. You know, we were on the rim on Friday and we're on the river on Saturday. And we had just great first class hotels and museum or meals and transportation. It was just a blast. It was the easiest, most relaxing, most informative trip that I've been on. And I just encourage anybody, if you can swing it, he does it, I think, once a year. And I think Jay Seegert might do a trip too, but I think that it's a lot of fun. If you can do it, by all means, do it.
Yeah, that's definitely on my bucket list. I have to do that one day. I'll make sure I do it at a time when you're going to be there as well, Brian. Therefore, we can fellowship in person. So
that's yeah. And then I got to speak at a church in Phoenix too. It was kind of neat how that happened.
Great.
Threw that all together. So yeah, it was a lot of fun.
Well, they would have been blessed then, Brian, to have you, because I really enjoy your presentations. They're engaging. You come with a lot of sources, a lot of visuals. You keep it fun. You have videos and audio. So this is great. You were here for a debate with Planet Peterson, but prior to that, you were here for a presentation, The Emperor Has No Clothes, if I remember correctly. That was an excellent program. We got a lot of feedback, and we've already got you scheduled for a couple more programs. And so for those who want to see Brian in another debate, well, we've got him taking on Mark Reed in an Origins showdown, creation versus evolution. This is sure to be a debate to remember. And we have our seminar event. And so this is coming up next month, which will be here soon. The hydroplate theory, guys, we are going to leave no stone unturned. Overview, predictions, and evidence. Here on Standing for Truth, we like to dig deep. We like to interact with all positions and persuasions in the world of origins. We've had a seminar on CPT, and now we're going to have a seminar on HPT, and this is going to be rigorous. I'm really looking forward to it, Brian. I think that's going to be great. And I'd like to put a challenge out there to anybody in the evolutionary community. If you watch this program and you see Brian's evidence, and it's going to be evidence-packed, put it that way, and you want to schedule a debate on the Grand Canyon, because we do still want to do a debate on the Grand Canyon in the future, perhaps in August, as obviously we're going to be busy here over the next couple months with Brian's seminar and debate with Mark Reed. Reach out to me. maybe you're a geologist, maybe you're an expert at the Grand Canyon, and we'll work out the details. So with that, Brian, my brother, I think we're going to get right into it. I'm looking forward to your presentation and what you have here for us. And so whenever you're ready, we can get up your slides or however you want to start the program. Brian, I'm just going to hand it over to you, brother.
Yeah, that sounds great. And I do appreciate what you do, Donnie, giving all these different insights a microphone, and so they can be discussed openly. I do appreciate that. I think that's what science should be, have a competing hypotheses. And yeah, so I'm going to start with the clip notes of my talk. I got out there, and the reason I went to the Grand Canyon was to get some footage. So there's a videographer from California. He wants to do a hydroplate documentary. And so we met up at Grand Canyon. We got some footage from the rim at me explaining the Grand Canyon from a hydroplate perspective. And it was a lot of fun because it's just a beautiful place, wonderful, full of awe and wonder, but it's also very mysterious. If that river cut that canyon, what cut the side canyons? Because there's no river there and they're just as deep. And why did that river flow through the Kaibab Plateau instead of around it? And how does a little river 300 feet across, cut a canyon 10 miles wide? And then also, why did it cut down into the hard crystalline rock of the inner gorge instead of getting wider into the softer sedimentary rock? So those are three or four questions that are pretty difficult to answer, but we're going to take a stab at it. The key to Grand Canyon is bulging and cracking. And let me see if I can share this all right. Let's see, we're going to share the entire screen. Bear with me real quickly, and we'll get up to this. We're going to jump in, and this is wanted, another debater. So that's what we want. If Jackson doesn't want to do it, we'll see if somebody else does, or maybe he can do it in the future. But I do kind of understand why he didn't want to do that, because there's some tough questions to answer on this topic. And so to set the stage for this, bulging and cracking 3 times, that's the key to Grand Canyon. And to set the stage, you have to realize that there was 2 huge lakes on that Colorado Plateau. And that Colorado Plateau is huge. If it was a state, it would be the 5th largest state behind Montana. And these lakes, that Grand Lake, that's at 5,700 feet. So it's a mile above sea level. So that's tremendous potential energy. It's twice as big as Lake Michigan in both size and volume. Got 3,100 cubic miles of water. And it's a huge lake. It's deep. If you looked at, if you're in Farmington, New Mexico, you'd be under 350 feet of water. That's a deep lake. But if you were in Grand Junction, you'd be under 1,100 feet of water. And if you were at Page, Arizona, that's 1,400 feet. And so once that starts going over, there's no stopping it. And I love this website. This is topographic-map.com. You can zoom in, you can tap, and whatever you tap, it shows you the elevation. Okay, and so there's the Grand Canyon in the circle there. Those are the cities that I mentioned, and that's not the elevation. That's how deep they'd be underwater. But let's just zoom in on Grand Canyon and look at that funnel. That's Vermilion Cliffs on the left and Echo Cliffs on the right. And at one time, they were connected. Those are 2,000-foot cliffs, and that's what's holding back Grand Lake. And eventually, it goes over the top, and so it cuts a slit down, and it erodes everything. It goes down to the Kaibab limestone, and then it hits the hard Kaibab limestone rock. That's 350 feet thick. And so that's why we think this happened a time after the flood, not right after the flood, because we need things to solidify. And so it's going to be, I don't know, maybe 100 years after the flood. I'm not sure, but it needed time for the hard Kaibab limestone to get solid, and also for those cliffs to get solid. Otherwise, if it was all mud, they would just sloop in. Okay, so it cuts down to the Kaibab limestone, and then it spreads out and makes that funnel that you see right there. And then it erodes the stuff off the funnel, and now there's nothing pushing down on that hard Kaibab limestone, so it bulges and cracks. And that crack, then it flows through the crack, and it cuts that Marble Canyon 61 miles down to where the Little Colorado River meets, and then it undercuts Hopi Lake. Now, Hopi Lake's about the size of Lake Huron, and it's 250 feet higher than Grand Lake, and it's coming down with tremendous force. And now you got 2 lakes that are just catastrophically draining, and it's sheet eroding everything on top of the Kaibab limestone. And now there's nothing pushing down on it. Oh, and you see those little arrows there? The horizontal one is point at Red Butte. You'll see that in when you drive up from Phoenix. And then the other one is by the tower on Desert View. And that's, they call it Cedar Mountain, but it looks just like Red Butte. So I call it Cedar Butte. Okay, that's what was left. I mean, that used to cover the whole thing, 1,000 feet of sediment there. It all got sheet eroded. And now instead of just the Kaibab limestone bulging, that whole plateau bulges up, that rises up, bulges, and cracks. So now that water that was sheet eroding everything, it goes through the crack, cutting out Grand Canyon. The sheet eroding on top, that's the great denudation. That's 2,000 cubic miles of sediment that had to be removed before you could cut the Grand Canyon. And then once it cracked, then it cuts out the Grand Canyon and removes 800 cubic miles. Now on the trip, they were saying 900 cubic miles. And in Walt Brown's book, it says 800. So between 800 and 900 cubic miles of sediment are removed from Grand Canyon. And now there's nothing pushing down on the basement rock. So that bulges and cracks. And when it was cutting through the Grand Canyon, it was cutting through below the water table. And so now the water from the sides were gushing in, and that formed the side canyons. And so the canyon forms the river. The river didn't form the canyon. Okay, that's the Grand Canyon in a nutshell. We're going to dive in a little bit deeper. And again, that is deep and wide, isn't it? And we're going to take a look at Grand Canyon facts tonight and some questions that I don't think Jackson wanted to ask here, and also how the government explains the Grand Canyon. And we'll take a look at the real answers, what makes sense. And then we have to figure out, how did that plateau rise in the air? And again, the key to all this is bulging and cracking. Okay, now here's some facts. Okay, we need to know what facts are and what interpretations or judgments are, or conclusions. Okay, and this is a science textbook from St. Cloud State. It says, separate facts from conclusions. A fact is a verifiable piece of information, whereas a conclusion is a judgment based upon the facts. The news media often mix facts with conclusions without indicating which is which. Well, that's the ultimate pot calling the kettle black, because science does the same thing. They mix the facts with the conclusion, and they don't tell people. For example, we went and we got a picture at this balancing rock, and there was a placard there that said, 2 points early to middle Triassic, 246 to 235 million years ago. That's what happened. They're stating it as a fact, but that's a judgment. They don't know that. And then it also talks about this conglomerate, 227 to 225 million years ago. They're stating it as a fact, but it's not a fact. That's a judgment or an interpretation of what they see. Okay, and so what do we have here? The fact is Grand Canyon exists. Been there, done that, took the picture, and it exists. Okay, the blind chance conclusion, and blind chance, by that I mean big bangers and evolutionists. Big bangers believe that the universe got here by chance, and evolutionists believe people got here by chance. So I just lump them together and call them blind chancers. Okay, so the blind chance conclusion is that the canyon formed slowly by a little water and lots of time, where a creationist, and this is not religion versus science or science versus religion. This is blind chance versus creation. Okay, and I think we need to change the topic there, or define the terms there. A blind chance, it's like thinking this building I'm in got put together by chance. That'd be absurd, right? Well, how much more absurd to think our bodies got put together by chance? And yet, if that's all people ever see, they don't think, they just memorize. And so that's why it's so important, that you're doing, Donnie. I'm so thankful that you're letting other perspectives be discussed so people can think. Okay, so the blind chance conclusion was slowly and a little water, lots of time. The creation perspective is no, it was quickly with lots of water and a little time. And we're going to see which one the evidence actually verifies. And again, what happens is the blind chancers are really good at erasing the line between the fact and their conclusion. And you see it as you walk down the trail on the rim, the trail of time, a geology timeline. This is 3,010 million years ago. They just stomp it in the ground. That's not a fact. That's an interpretation. And then you go on this fossil hike, and you can see these fossils. That's a trilobite, I believe, that I found. And then on the way back, it's 3.2 billion years. That's not a fact. And we didn't do a whole lot of inside stuff. We kept on moving. We saw the sites. We didn't go inside much or at all at the government places. But here's another one, 3.8 to 1.75 billion years, the Vishnu schist. Again, that's an interpretation. That is not a fact. So what are the facts of Grand Canyon? Well, the Colorado River that's inside the national park is 277 miles. That's counting the 61 miles that's in Marble Canyon. Marble Canyon and Grand Canyon are a little bit different. Okay, the average width is 300 feet, so it's about the size of a football field. The minimum width is 76. The average depth is 40 feet, and the greatest depth is 85 feet. And what they don't tell you is there's a bunch of boulders and stuff on the bottom of that river that so that river's not cutting the canyon anymore. It might move the sediment on top, but it's not cutting the canyon. It's not getting down there that far. And the average gradient is 7 feet per mile. Okay, and then the Phantom Ranch is at 2,400 feet. Those are the facts. Okay, and now let's take a look at some conclusions. This is from their website, the National Park Service website. They got the landscape and resources ranging from 1,840 to 270 million years old. That's an interpretation. It says the Colorado River established its course through the canyon about 6 million years ago. Again, that's not a fact. They are interpreting things. That's a conclusion. And then the geologic record in Grand Canyon is an important scientific chronicle. Again, those are interpretations. Those are not facts. They're all conclusions. Okay, and what I wanted to do was find out what's the elevation of when the river flows in to the canyon and when it flows out. So here's a hint. Phantom Ranch is 2,400 feet. Okay, that's the elevation of the river there. And so I look on the map. Well, okay, that's in the middle. But what is it when the river flows in and when it flows out? I could not find it on the website. I did find that the Colorado River descends about 2,000 feet in elevation, but that doesn't tell me where it is flowing in and where it is flowing out. So I use this fun topographic map. This is a lot of fun. I went into Glen Canyon. I went there and I tapped above Glen Canyon Dam, and it's 3,600 feet. Then I tapped below it, and it's 3,100 feet. Okay, and we were in that Glen Canyon. It was a lot of fun. And then at that Lake Mead, this is after Grand Canyon, it's about 1,200 feet. So that's roughly 2,000 feet. That's exactly what the website said. But I wonder why they don't tell us when it flows in and out. Because the first question is how did the river flow uphill to cut the canyon? If it flows in at 3,100 feet and it flows out at 1,200 feet, how in the world does it cut a canyon that's 7,000 feet? Rivers don't flow uphill. And they even admit that in the website. So that's a tough one. Okay, and then how do side canyons form without a river? That's a tough one. They're just as deep, but there's no river. And why are the canyons longer to the north than to the south? And why didn't the river flow, or why didn't the river flow around? That's worded wrong. Forget that. Why did the river flow around the Kaibab Plateau instead of through it? Because you use this. There's the Kaibab Plateau, and you can do this is on the rims. It's like 9,000, a little bit north, 9,000 feet. But on the rims, the north rim is 7,300 feet. On the south rim, it's 7,000 feet. Okay, so but over here it's 4,800, 5,300, 60. The river should have flown around the side. It could have easily gone around the side, and it could have gone around the north too. There's 5,200, 756. But why did it go through the canyon? And how does a little river cut a canyon 10 miles wide? That's a real tough one. And then why'd the river cut it down into the hard crystalline rock of the inner gorge instead of getting wider in the softer sedimentary rock? I think that's probably the hardest thing for them to explain. And this guy, he used to give tours there, and he'd show people the canyon, and he said, yeah, I dug it. And then a little kid asked him, well, where'd you put the dirt? And that question haunted him the rest of his life. Where did that dirt go? The delta, that's only got about 1% of that 800 cubic miles that got removed. And this is what Brian Nickel does. He does a really good job. That's probably the best Grand Canyon video out there if you want to dive in deep. He's got a YouTube channel called Brian Nickel, and then he's got the origin of the Grand Canyon. Here's some screenshots from it. But it's got the Colorado River, and then it compares them to all these other deltas, and it's really small, rather small. And the other ones, they didn't cut such a big canyon, but the Colorado did. And so, and then what forest removed 800 cubic miles from the Grand Canyon? But before he did that, you had to remove 2,000 cubic miles from all that area. Tens of thousands of square miles had to get moved from there. And there's that red butte where that star is. And again, that's 1,000 feet of Mesozoic sediment capped with volcanic rock. And we'll show you how that happened at the end. but there's a real similar one. This is one we took a picture as we're going by in the bus. Oh, and that bus ride was so much fun. There's 50 creationists there. It was just great. First class the whole way. And I asked the bus driver, what do you do when these things are over? He says, well, then sports starts. And he says, yeah, he gives bus rides to high school and college and pro. And I said, pro, really? And he said, yeah. And I said, are they pretty nice guys? And he said, some of them. And I asked him, well, who's the nicest one? And he said, Steph Curry. And he said, but the nicest all time was Tony Parker from the San Antonio Spurs. So anyhow, but it's a lot of fun. And this is Cedar Mountain. You see this up at Desert View where that tower is. Looks just like Red Butte, except I don't think it has lava on top. Okay, and then how does a 5 to 10 ton rock get raised into a sedimentary layer of rock? You notice there's that rock. You know, it's about a man could lay on it, and it came from the bottom right, and yet it got lifted into the top center there. And it's at Isis Temple. It's a 2 days hike, so you need to know what you're doing if you're going to go there. And that's what Walt Brown did with his grandsons. They took that hike, and you can notice how the sediment just kind of curves around the top part of it. This was not laid down millions of years. And this is a really tough question for a blind chancer. You know, how does that 10-ton rock get lifted from the stuff down there up there? I'm thinking that it's the wrong perspective of the past. Okay, how did this funnel form? That's just south of Page, Arizona. And that's the Echo Cliffs and the Vermilion Cliffs on the left and the Echo Cliffs on the right. And they're at 7,200 feet, 6,700 feet. And then that floor in between them is at about 4,800. And on this cliff, on Echo Cliffs, there's a pothole that's formed in fast flowing water. There's a rocket that gets caught in a vortex and it digs that hole out. It's about the size of, I don't know, it looks like it could be a hot tub. And so the question is, how do potholes form 3,300 feet above the river on a 2,000-foot cliff that's over 4 miles away from the river? That's a tough one. And you can see this on page 233 there's a flip book. You go into hpt.rsr.org and you can see a flip book. And I think that's the 2008 edition. I'm not sure, but that's on page 2003. And there it is again. And then it goes and it says, why was water flowing so rapidly this high, 6,600 feet above sea level and at an upper edge of a 2,000-foot cliff? Yeah, they don't mention that at Grand Canyon in the brochures. And then how do barbed canyons form? My brother-in-law was taking a geology class at St. Cloud State, and they spent the week trying to figure out how Grand Canyon got there. And they looked at all these theories, none of them worked. And the professor said, there's one theory we haven't talked about. Anybody know what it is? Kid raised his hand and said, Noah's flood. And it got real quiet. And the professor said, you're right, but we can't talk about it. It's like they didn't have an answer, but they wouldn't look at one that came from the Bible. Now, personally, I do not think this happened right after the flood, because those spires, if that was mud, when all that water went through, it'd wipe it all out. They would all slump. So again, I think it took 100 or 200 years for things to solidify, get more stable before the flood came through. But my brother-in-law said the thing they could never explain was these barbed canyons. Okay, and what are we talking about here? The blue line, that's the Colorado River. It's flowing to the southwest. But those canyons, those tributaries, are flowing to the northeast. And if you don't believe me, you can play with that type of topographical map website, because this canyon starts at 5,500 and it goes down to 5,300. So it drops 200 feet. This one drops 200 feet. This one drops about 100 feet. This one drops about 300 feet. This one drops about 200 feet, 150 feet. So they're all dropping, going to the northeast, and yet the river's flowing to the southwest. That's a tough one. That's a real tough one. And then why are the layers so flat? I mean, you look at the Kaibab limestone on top, it's got a bunch of erosion marks in it. Why aren't there erosion marks in all of them? And why are they so sorted so well? And that, look at this, like pancakes laying on top of each other, one laid down right on top of the other. There's no erosion marks. And then also, how do you get these slanted layers underneath flat layers? That's a real tough one too. What's the mechanism? What's the force? What's the energy that would do that? Well, by the end of the evening, you're going to know how that happened. And then why are 7 of the 12 geologic column layers missing? And keep in mind, the geologic column does not exist anywhere except the museums and the textbooks. And, it's like if I'm in Minnesota, if I start digging right now, I'm not hitting dinosaurs. I'm not hitting the dinosaur layer. I'm going to hit granite. Okay. And then what they aren't telling, how do you miss? Okay, maybe just to humor you, it exists, but let's say the top one's got eroded off. How about the second and third from the bottom, the Ordovician and the Silurian? They're missing. That's 72 million years that are missing. They're just not there. And the website, it doesn't mention them. It mentions the other ones, but not those two. Very deceptive. Okay, and what force crushes basement rock? And that's the Vishnu schist. That's the bottom. That's the basement rock. And that's what the inner gorge goes through. You know, how does that happen? Those are all compression cracks. And then why is the Schnebly Hill formation missing in the Grand Canyon? Because in the Grand Canyon, you got the Coconino sandstone right on the Hermit Formation, but you go 70 miles away, and now it's separated by 800 to 1,000 feet of the Schnebly Hill Formation. And if you want to see more of that, Dr. Andrew Snelling talks about that. I think he talked about it on his Genesis history, but also how do rock layers show a young Earth? That's on YouTube, so you can check that out. And again, I'm not a scientist. I'm a megaphone. I tell people what the scientists are saying, you know, because if nobody knows what they're saying, who cares what they say? So I'm trying to magnify their voice. And again, okay, what force raises a plateau a mile high? Because that's a double, you know, this is a plateau mystery. This is, let's see, where's this from? Kennedy, The Origin of Continents, Mountain Ranges, and Ocean Basins. And he says, what mechanism would cause a large volume of low-standing continents to rise rapidly a mile in the air? We then have a double-ended mystery for the Colorado Plateau seems to have grown downward at the same time that its emerged part rose upward. Yeah, how does that work? And if you want to look at the Himalayas, that was like 3 miles in the air. What's the force? I'll give you a spoiler alert. It's gravity. Gravity is the force. Hydraulics is the mechanism. So that's the spoiler alert. We're going to get to that. Okay, now let's see how does the government answer these questions? Well, actually, they don't. But this is their website. You can go. This is National Park Service. This is nps.gov/GRCA. That's going to give you the Grand Canyon website. And let's take a look at what it says. The story of how Grand Canyon came to be begins with the formation of the layers and layers of rock that the canyon winds through. The story begins about 2 billion years ago. So this is a story, folks. This isn't science. And where did we see this before? This is the Earth Science textbook at St. Cloud State. The origin of the geosphere is the story of the birth of our planet.
Brian, I think your mic just went on mute.
Boom. Okay, what's the last thing that you heard?
Oh, it just went on mute maybe 2 seconds ago. So I would just rewind what you were saying. Maybe reiterate your last point, Brian.
Okay, the last point is these are stories. This is not science. And I'm glad you're awake. That's a pleasant that's a good thing.
Well, these are a lot of tough questions and challenges. I was just saying in the live chat.
All right.
To old earthers and evolutionists. I'm glad I'm not an evolutionist debating you tonight, Brian. This is great. Keep it up, brother.
Cool. Is my screen still sharing? I'll push play.
Yes. Yep. As long as you put full screen. Yeah, there you go.
There we go. All right. So this is a story. This is not science. And we talked about that. And then it goes on to say on their website is scientists know that the Colorado River carved Grand Canyon. How do they know that? Were they there? Did they observe it? Because science is observation and testing. Did they observe it? And how do you know that? That's an important question. I'm starting to ask that more and more. I was at a state park that had a placard that said the stones formed 2 million years ago. So I went to the ranger station and I asked, how do you know that those stones formed 2 million years ago? And they both pointed to the boss, and the boss came up and said, well, that's what the smart people tell us. Well, I said, those smart people have a blind chance perspective of the past. That's like thinking this building got put together by chance. That's absurd. And then a worker in the back is nodding her head in agreement. And I said, if you're going to teach a belief system, you should teach both of them. You know, teach the creation perspective also. And if you're not going to teach both of them, then don't teach either of them. You know, either teach both of them or don't teach any of them. Just tell us what you got. We got rocks, we got water, we got trees. You know, throwing the millions of years in there without evidence as a taxpayer, I think that is not. I don't approve of that. Let's just say that. Okay, and so they know it. My question is, how do you know that? Okay, but that's the one chapter of the book that they're not changing. That's the chapter, the story that's the sacred cow. Don't question that. Okay, and then it goes on to say the Kaibab Plateau, a high point through which the river gingerly slices, poses a problem for geologists. Oh, really? Well, I didn't see that in our textbooks. It says water certainly doesn't flow uphill, and we talked about that, and we understand that, but that's not in our textbooks. Nor was it in the placards. I didn't see it anyway. Okay, while keeping these few accepted chapters in the Colorado's Rivers history book in mind, geologists have proposed a number of different hypotheses. And that's good. We should have different hypotheses. Okay, and this is Forbes. The mystery of the Grand Canyon's missing billions of years may be solved. Well, I didn't see any missing billions of years as I was stomping around Grand Canyon. I didn't see any missing billions of years when I was reading about it in our textbooks. So what are they talking about? The great unconformity has perplexed geologists since it was first described 150 years ago. So what's the problem? Okay, the 500 million year old Tapete sandstone is directly overlying the 1.4 to 1.8 billion year old Vishnu schist. Yeah, they're missing about a billion years. And it says, think of the red bluffs and cliffs of the Grand Canyon as Earth's history textbook. You can jump back almost 2 billion years in the planet's past, but the textbook is also missing pages. In some areas, more than a billion years worth of rocks have disappeared. Just disappeared. Okay, this is a story that has huge gaps of time. Okay, and then it goes on to say some, their hypotheses, but look for fuzzy words. May have, likely. When you find stuff like that in a sentence, just cross it out. That's not science. That's imagination. And they want these teams findings could help scientists fill in missing pieces of what happened. Yeah, we have the missing pieces. We can tell you what happened. I submitted it to the Park Service. They haven't put it up there yet. We just need some more people to submit this hydroplate theory. And then it'll make sense. Okay, let's take a look at these. They got 4 hypotheses on the National Parks website. Okay, the first one's the Little Colorado River hypothesis. And in order for this theory to work, the ancestral Colorado River would have needed to flow eastward over the Continental Divide. There is, however, no evidence in the Colorado River drainage system to support the idea of an eastward flowing river. So throw that one out. The northwest flowing river hypothesis, in order for this to work, the Kaibab Plateau couldn't look like it does today. And unfortunately, no sedimentary deposits have been found to support this theory. So throw that one out. And then the spillover theory. They're getting close. They're getting close. It says the ancestral Colorado River was temporarily dammed behind the Kaibab Plateau and other high points. Wait a minute. If that's the case, it would have flowed around the bottom of it or around the top of it. It would not have flown through the higher middle part of it. So throw this one out. And then it's got the collapse of a groundwater karst system. It's the collapse of the groundwater. And that's a very new idea. They don't have evidence for it, but they're developing it. And I'm saying, put the hydroplate theory up here. This is catastrophic, not millions of years. And that's, I think, the big problem is they need millions of years to prop up their blind chance perspective of the past. And they've only got so many icons they can use, and they don't want to lose one. But if you want to learn more about this, go into RSR, that stands for Real Science Radio, rsr.org, and search Grand Canyon Month. And you're going to hear stories that Brian Nickel and Bob Enyart did on a list of problems with the river carved the canyon. It's just too small of a river. There's no way. And we talked about those problems. And a list of problems with the canyon's millions of years. That's a fun one. Those layers were not laid down over millions of years. And then a list of problems with the flood carved the canyon. And again, I don't think this formed after Noah's flood, because if that's the case, there should have been everywhere. Everything should have a Grand Canyon. Okay, and what I really like, and this is Dr. Walt Brown's hydroplate theory in the beginning. This is the 9th edition. You can download this online at rsr.org/HPT. And there's underneath the cover, it says 9th edition. And then you just click that. You can download it. You go to page 237, and you've got all the theories on the top, and you've got all the features on the side, and then red, yellow, and green. Red says it explains it. Green says it explains it. Red says no, and then yellow's kind of. But let's take a look at that. There's 9 theories on the top, and a lot of red and yellow under them. But if you look at the Brown's hydroplate theory, that's all green all the way down. And that's, why is it here? Why is it here? If millions of years that's all you need to cut a canyon? Well, the rivers have been flowing millions of years everywhere, elsewhere on Earth, wouldn't they be? There should be Grand Canyons everywhere. Okay, and what's the force and energy and mechanism that's going to cause this? And again, those lakes a mile in the air, that's the key. And how do you get them up there? Okay, and the side canyons, again, the side canyons, they don't have a river, but if the canyon was cutting it through below the water table and the water table came in on the sides, okay, and then the barb canyons, we took a look at them, and there's missing Mesozoic rock over tens of thousands of square miles. And the inner gorge, it shouldn't have cut into the inner gorge. It should have got wider. And then there's missing talus. I don't know if you know what talus is, but that's the debris as a cliff crumbles. It's going to freeze and melt and freeze and melt, and it's going to crumble. And when on Saturday, a week ago, I was on the river in the Grand Canyon. And I tell you what, man, if you can get that that trip, it's going to be so much fun. And these are $100 raft trips if you were to go by yourself, over $100, and it's just so well organized. And our river guide, her name was Mo. She just did a great job. Oh, and the water's cold. It's really cold because it's coming from the bottom of the reservoir. So it's cold. It's not Lake Superior cold where it makes your toes numb, but it's cold. And you could get in it too, and I did, but it was a lot of fun. But going back to the talus here, you see how it's that gravel pit kind of there leaning up there. She says that's new because there's no grass growing on it. And you can also tell from the cliff because there's no varnish on that cliff. So that's new. And she says she's seen them happen in the lake before. She said it sounds like dynamite, just boom, and then it crumbles in. And I was listening to Eric Hovind and Russ Miller talk after that talk when we were there. It's like, if this was millions of years old, this should be a big V. It shouldn't be so straight up and down with millions of years of talus. We don't have millions of years of talus in the Grand Canyon. So what formed the Kaibab Plateau? Where'd the missing dirt go? And then the tipped layers below the unconformity. And again, the hydroplate theory, it knocks it out of the park. It's green all the way down. Everything else is red and yellow with a couple of greens. And this is a theory that should be discussed. And it's a shame that they're not discussing it at creation conferences. We submit papers and they get rejected. And I mean, there should be always have competing hypotheses. That's what Dr. Thomas Chamberlain said over 100 years ago. We should always have competing hypotheses so people can think critically. They can analyze and compare. They can sharpen their analytical skills. Otherwise, they just memorize and conform. And if we want blind chancers to have a diversity of thought, allow for a creation perspective, creation organizations should allow a diversity of thought and allow for the hydroplate theory, because this theory will destroy the Big Bang when it gets into the mainstream. The NASA discoveries and its accurate predictions are accurate, and Big Bang is wrong. And so that's a little rabbit trail. Okay, let's take a look at what these conclusions are based upon. It's this geologic column. And they had them all named and layered back in the 1879. This was not put together with radiometric dating. This was put together with horse and buggy technology. 1879, that's when we got the light bulb. But this is the New Testament for a blind chancer. And they will not change the dates, even if they find soft tissue in dinosaur bones, even if they find nerves and bone cells and collagen, which can't last millions of years. They need a rescuing device, but they haven't imagined one yet. So they have to imagine that they're going to imagine one. But this is the New Testament for the atheist, and they can't change it. And the Old Testament is the Big Bang, and they'll slap that together with anything: dark matter, dark energy, inflation, string theory. It doesn't matter, as long as they don't throw it away. Okay, so that's built on that, and that's a bad foundation. Okay, going back to the national website, the National Park website, it says layers from the Cambrian, Devonian, Mississippian, Pennsylvanian, and Permian periods are present. Well, that's nice, but it's also very deceptive. Where's the Ordovician? Where's the Silurian? They tell us what's present, but it's very telling when they eliminate what's not there. They ignore it. Why do they ignore that? Well, that's kind of hard on the millions of years. That's kind of hard on the blind chance perspective. And so that's a very deceptive statement. I hope they get that fixed. And maybe they did. This was a couple of years ago. I put this together. Hopefully they got it fixed now. But again, if they haven't, that's very deceptive. And then this is a children's one. Yet over millions of years, these bones, shells, footprints, leaves, and other remains turned into stone. Okay, millions of years, footprints turn into stone over millions of years. If you go walking in the mud, are those going to turn into stone? No, they're going to erode. No, and talking about fossils, we can do an experiment, observation and testing. That dead deer on the side of the road, or dead armadillo, or whatever roadkill you get, is that turning into a fossil? No, it's going to get scavenged and decompose. The only way a fossil forms is if it's buried rapidly. Therefore, any layer of rock that has fossils in it was laid down rapidly. And that's the whole geologic column. Okay, the fossils are a sign of a flood, not millions of years. And if this is over millions of years, explain the nautiloids. This is from Steve Austin's book, the fossil nautiloid. The nautiloids are like a snow cone with a shrimp coming out of it. They're about the size of your forearm, and they're all oriented in a certain direction. And this is on page 165 of his book, The Guide to the Grand Canyon. It says he finds one fossil per square yard. And the fossils in their directional orientation indicate that these nautiloids experience a mass kill event, not natural death. Then 15% of them are standing upright. How in the world do you do that? And I was on a creation adventure with a bus, and I was able to share a seat with him, and we talked about this. And he said that when he submitted his report to the National Park Service, they took away his permit, so he couldn't do it anymore. And somebody else, they won't give a permit either, and so they sued. He wanted to sue, but the ICR didn't want to. But somebody else did sue, because we have just as much right to go there as anybody else. Okay, but 15% are found standing upright. Okay, well, let's take a look at this Redwall limestone. How long does it take for that sediment to get built up? So this says it's 500 feet thick, and if you do the math, it's 500. It's 50 million years. So you do the math. It's 1 foot every 100,000 years, and so that's to build up 1 inch, it's 8,000 years. And that nautiloid's supposed to stand there about, if it's 12 inches long, it's going to stand there for 120 years to get fossilized. No, I don't think so. I don't think so at all. And then going back to the website, National Park website, it says, perhaps the biggest question of all, how the Colorado River chose this course and began carving the canyon, still awaits a clear answer. Well, that's not what they're putting in the textbooks. It's like this got cut over 6 million years. But according to the website, and I appreciate them putting that there, they don't know how it happened. That's why they should look at the hydroplate. And I think more and more people should submit this to the National Park Center if they're there to educate us. They'll put it in there so we can see both their theories and think. But if they're there to indoctrinate us, they'll keep kicking it to the curb. All right. Okay, so here's some of the answers. Okay, now this is what we need to understand. In order to cut the Grand Canyon, to cut the 800 or 900 cubic miles, in Walt Brown's book, it says 800 cubic miles. The guides I was listening to last week, they were saying 900 cubic miles. So it's right in there. And so before we can remove that, we got to get rid of 2,000 cubic miles from the Great Denudation. That's like the Echo Cliffs that went all over that area. That's Mesozoic sediment there that all had to get removed. But before you could remove that, you had to have the Grand Staircase. Yeah, that's 133 cubic miles. And this is from Wikipedia, neat picture. Notice that arrow on the right. That's the Kaibab limestone. And that's what you stand on at Grand Canyon. And follow that to the left as it dips down. And that's going to down to like 4,000 feet. And then there's other layers going up to 11,000 feet. So there's over a mile of sediment that had to get removed from that Kaibab limestone before you could get the Great Denudation. Okay, the Grand Staircase. Now, I think a lot of those layers got taken off. So those could have been taken off after the flood, when you got big tsunamis going by and they're going to sheet erode everything, and it's going to erode that. That's my personal opinion. And we're going to be taking a look tonight at, A is the Grand Canyon, all right? And C is Vermilion Cliffs. That's what we're going to be looking at tonight. Between those two areas, between A and C, that's what we're looking at. And then if you're just for information's sake, E is where you got Zion Canyon, and H is Bryce Canyon. And all of these those have something to do with the lake draining. I don't know if it's removing all that stuff, but it has something to do with the lake draining. Okay, a satellite picture shows this orange stuff. those are lake beds, huge lake beds. The top two, that's going to be Grand Lake. The bottom one, that's going to be Hopi Lake. So you got these huge lakes up on this Colorado plateau. And notice all the national parks and neat features there. That's the Grand Circle there. You got Zion and Bryce and Arches and Canyonlands. And see, it's not just the lake that has water. There's a lot of water-saturated sediments there. And there's some people think that there's more water in the sediment than there was in the lakes. And so just look at Bryce Canyon, the water's coming out of there, and Zion, and I think that's how they get those Hutus. But let's just take a look at Arches. Okay, Arches. They're collapsing at about 1 a year around the world. And it's the question that Dr. Randy Galuza would ask in college. He'd say, well, what process is forming them? You know, if we're losing about 1 a year, what's forming them? We don't see that. Okay, and then you can listen to this on rsr.org and listen to the story there. And then also Monument Valley. These are the mesas, buttes, and spires. How do you get them? Okay, well, underneath those features, there's 1,400 feet of sandstone. And sand is kind of roundish, so there's a lot of room for water there. And I'm not sure how deep it was here. Let me see, where was that? Yeah, because up there, that could be 1,000 feet deep up there. Okay, because up where the bow is, that's Grand Junction, that's 1,100 feet. So if there's 500 or 1,000 feet of water there and it gets drained, all that water is going to come to the surface and then it's going to erode it away. But if there's something blocking it on top, it's going to erode out the side. That's how you get the mesas, buttes, and spires. Okay, what else do we got? We got the petrified trees. Okay, this is at the bottom of Hopi Lake, the southeast corner of Hopi Lake. You've got this petrified wood that's really different from other petrified wood. I don't know if you can see me here. Okay, because I've got petrified wood in the past, and it's tan and it's brown. This is from the petrified forest of Mississippi, and it's kind of neat. You can see the grain in it and stuff. And then I got this. Okay. Me now, Donnie. Wake up, Donnie.
You're back, Brian.
Okay. Sorry to wake you up.
Hey, no problem. Oh, I'm not sure what you're doing to have the system mute you, Brian, but
right. Hopefully I just won't move something. It's very delicate here. Okay. All right. I got this piece of petrified wood from the Navajo Nation, and it's different. You got different colors. You got this brown and tan, but this one has different colors. I think this one petrified in the dirt. I think this one petrified in the water. And Walt Brown says that Hopi Lake and the other lakes, because there's petrified trees up in the Grand Canyon, Grand Lake also, he said that it was rich in silica, and we'll explain why that happened. And then as the lakes cooled off, the silica came out of solution and went into the lakes. That's why I think these are different. They have more color than these, which I think became fossils inside of the earth, in the ground. Just my thought, take a, it could be right, could be wrong, just something to think about. That's my 2 cents. And we are going to share again, I think. Present. Okay, present. Share screen. Okay, I think we're going to be back at it. All right, and then we're going to roll again, hopefully. Sorry about the delay.
You're doing good, Brian.
All right, let's find it.
Smoothly. Brian, you just went on mute again. I think you're still on mute. I can see your mouth moving, but nothing's cut. There we go. You're good, Brian.
Okay, I'm going to keep that pushed in then, hopefully. Yeah, this is very, very sensitive. Okay, we're going to try it again. Can you see that?
No, I think you have to share screen again.
All right.
As you're doing that, Brian, I'll let the audience know. I do have the link pinned for anybody that wants to join the live call-in section of this program. I've also got several of my own questions and several text questions that have been sent in. So we should be having a good, solid, interactive program. I will give evolutionists and critics precedence, as in allow them to ask questions and discuss the topic first, because I know some people want to see a bit of a debate tonight. And then for creationists, we'll still give you the opportunity, of course, to ask your questions live. Brian, I do see your slides are good to go.
Good deal.
And okay, floor is yours again.
Good deal. Yeah, and these are a whole lot different. I've seen a petrified forest in North Dakota, the Teddy Roosevelt National Park, and they're just brown stumps. They had no color. This is something different happened here, and a really good. If you want to see the how the lakes made all those different features, Mike Snavely's got a really good video called Grand Canyon: The Puzzle on the Plateau. And he also has footage from Zion and Bryce and Canyonlands and Prairie du Chien and maybe even the Petrified Forest. He does Grand Canyon expeditions too, or he does the Grand Circle. The Creation Today trip that I was on, it was fly in Thursday, fly out Sunday, and it was a lot of fun. Mike Snavely's got one that's more like 8 or 9 days where he goes to all these different ones. And so I think that if he got some creation interest, he would be a really good person to see. Okay, so now you got Grand Lake. We talked about that, and we talked about how deep it would be, and we talked about Hopi Lake, how big that is, about the size of Lake Huron, and we looked at those already. And so now on the left, there's Vermilion Cliffs. That's holding back Grand Lake. And what caused it to go over? There's a couple different ideas. It could have just filled up with the rain that was coming down during the Ice Age. It's coming down as rain here instead of snow in the north, and it overflowed. Otherwise, it could have been there was a lake that was upstream that breached and made this one go over and breach, or also could have just slid. It could have block faulted up to make it higher. But whatever happened, it started to go over right around Page, Arizona, and that's where we get the funnel. It breaches right there. And so now you got tremendous potential energy there, twice the size of Lake Michigan. And once that starts flowing, there's no stopping it. And it starts going, starts flowing through there. And that's how you get the potholes on a 2,000-foot cliff, because it wasn't a cliff at that time. It's just water gushing through at tremendous velocity. And then it cuts down to the hard Kaibab limestone, and then it makes this funnel. It spreads out, and it's 12 miles at the end of it. And to put that in perspective, to compare that to Niagara Falls, that's how wide it is compared to Niagara Falls. Okay, so this is a lot of water, and water can do a lot of damage. And so it erodes everything on top of the Kaibab plateau or Kaibab limestone. So now there's nothing pushing down on it. So it bulges and cracks. This is the first one. We're going to do this 3 times. This is number 1. Bulges and cracks. And then the water goes in that crack and cuts the Marble Canyon, and it for 61 miles. And then it undercuts Hopi Lake, which is 250 feet higher than Grand Lake. And now that starts to erode catastrophically, and it's just sheet eroding everything on top of the Kaibab limestone. You got two great, enough water for 3 Great Lakes, catastrophically draining, sheet eroding everything on top of the Kaibab limestone. Okay, and Walt Brown says that Hopi Lake's high shoreline, a waterfall about 13 times higher with possibly 100 times greater flow than Niagara Falls. So this.
Brian, you went on mute again. Is it your cord for your external mic? It must be really sensitive if it is it a plug? Is it a plug and play where you just plug in the external mic and it?
It's the gadget. I have a MacBook Pro, and I have to plug it into an adapter. It's not going directly into my computer. So it's very sensitive, and I was holding it the whole time. But yeah, thank you. So let's see, what's the last thing that you heard? Sorry about that, everybody.
Oh, no worries. And I caught it basically right away. So maybe perhaps reiterate the last point you were making, Brian, and we should be on track. All
right. Okay, so this is the Great Denudation. This is when 2,000 cubic miles are getting eroded away. This is when the 1,000 feet of Mesozoic sediment, that's Red Butte, that's getting all eroded. And we wouldn't even known that it was there, but Red Butte is a monument to the past, and also Cedar Bluff. And so this just sheet erodes everything. The 2,000 cubic miles of sediment are getting pushed down, pushed away. And now there's nothing pushing down on that whole area. So instead of just the Kaibab limestone bulging, now that plateau rises up. So the Kaibab plateau, I like to think of it as an upwarp. The Colorado plateau, that's the plateau. This is a bump on the plateau. So this, they call it the plateau. I think it's an upwarp, but whatever it is, it bulges up and then it cracks. So those two lakes that were flowing through, flowing through the top, now they flow through the crack, and that's what eats up the that's what forms the Grand Canyon. But before we get to that, let's take a look at what causes the barbed canyons. Why are they flowing to the northeast? Because this land rose up, and so now the groundwater is flowing that way, flowing to the northeast. And then it's going to hit the high-speed water going to the southwest, and it's going to zip around, and it's going to make the barbed canyons. And then how do you get the side canyons? Well, that river the crack was so deep that the water's cutting through so deep, it's above the water table. So now you got water gushing in from the sides, and that's going to cause it's going to cause the side canyons. And the north rim is 1,000 feet higher than the south rim. So that's got a lot more erosion that it can do. That's why the canyons are longer to the north than to the south. It's because it's higher. It had more groundwater. It drained farther. And some of these canyons are 11 miles long. If that river cut the Grand Canyon, what cut that 11-mile canyon? It doesn't have a river. It's the groundwater that's draining at that time, because after the flood, there's a lot of groundwater in the earth at that time. Okay, so how do we get the inner gorge? Okay, the inner gorge, 46 miles long, 1,200 feet deep at places. Okay, so, and that's right in the middle of the Kaibab Plateau, hint, hint. And it said the river cuts down over millions of years and it's going to hit the hard granite. It should get wider, but it doesn't. It doesn't. It goes into the hard crystalline rock. And why is that? Because when that 800 cubic miles was, or 800 or 900 cubic miles was removed from Grand Canyon, now there's nothing pushing down on the basement rock. So the basement rock bulges and cracks. And then the river flows through the crack. That the river didn't make the canyon. The canyon made the river. Okay, and so where'd all the dirt go? All that 2,000 cubic miles and 800 cubic miles go? Well, it's a big surge deposit. There's a big floodplain on either side of the Colorado for 100 or 200 miles all the way down. And Walt Brown says, just when you're driving, just look into the gullies and you're going to see these big boulders. 100 or 200 miles to the east and to the west of the Colorado River, south of Lake Mead, going down to Bullhead City, you see big rounded boulders. That means that it was powerful. It could move boulders, and it rounded them. That's a key. And then it's surrounded by sand. That means it stopped quickly. It didn't have time it just didn't erode the sand away. If it had stopped slowly over a long period of time, so the sand would have washed away and just left the boulders. Well, that's not what happened. And you see the same thing up in Wisconsin. There's a Devil's Lake State Park or something like that, Devil's something. But you see the same conglomerate. You see rounded boulders in sand. Okay, and then these large rounded boulders have been found a mile away and 100 feet above the water or the river near Bullhead City. So where is Bullhead City? It's down there. So when you're driving in that area, just look down the bridges, the gullies as you drive by. Okay, now we said all that. That's how it formed. Okay, but now the key to the Grand Canyon and why you don't see these anywhere else is what force raises a plateau a mile high. And also, how does a 5 to 10 ton rock get raised into sedimentary rock? And we can answer that with the hydroplate theory. And real quickly, for those who don't know, it was developed by Dr. Walt Brown, who was an Army Ranger, paratrooper. He West Point grad, got his PhD from MIT in mechanical engineering. He ran the Benet Military Lab. He taught at the U.S. Air Force Academy. So he's a sharp guy. The Benet Military Lab, there was dozens of PhDs working for him. And he was the top dog. And again, I'm not a scientist, but I'm telling you what he says. He did this book in the beginning, very well sourced, and I encourage you to check it out. And what he says, back in the 70s, he's driving through South Dakota, and he hears on the radio that somebody claimed to have found Noah's Ark on a mountain. And he thought he was a crackpot. And he thought, man, doesn't he know that That can't happen. But in South Dakota, there's not much to do. So I think that to keep his mind active, he just thought, okay, let's just humor him. If there was, if that's the case, they found an ark on a mountain. That means the whole world was underwater. That means that a bunch of plants and animals got buried in mud and turned into fossils. And he thought, wait a minute, if fossils are a sign of a flood, where's the evidence for evolution? And he began to ask his PhD friends and colleagues, and he didn't find, after 2 years, he didn't have any evidence for evolution. And then he noticed in the Bible how it said that there were springs in the sea, and how the fountains of the great deep broke up, and how the earth was laid upon the waters. And he thought, if there was water in the earth, what would happen? And he came up with the hydroplate theory. And if you want to see him explain it in his own words, you can go into my YouTube channel, Solidify Your Faith, and I have a playlist just for the hydroplate. I do think this theory will destroy the Big Bang once it gets into the mainstream. Okay, and you can listen to him explain it in his own way. So just think of, this is his one assumption. The fewer the assumptions, the better, and the more accurate predictions, the better. And he's got one assumption and a lot of accurate predictions. And because with a theory, normally we look at what we have, that's the effect, and we try and figure out what caused it. So we're going from the unknown to the known. This is different. He's setting up the cause with a known, just one assumption. Let's the laws of physics go at it, and it fits our world perfectly. Okay, so just think of the earth as a big apple. The skin is 60 miles thick, made of granite. Underneath that is a layer of water about a mile thick, and underneath that is the mantle. That's the one assumption. Okay, now let's throw the laws of physics. You throw the moon in there, which is going to tug on the Earth's crust. And back then, the crust wasn't broken into plates like it is today. It would just stretch. It would stretch and compress, stretch and compress, stretch and compress. If I had a wire bending it back and forth, it's going to get hot. Well, that's adding heat here. Heat goes into the water. The water gets hotter and hotter and hotter. It wants to boil, but there's no room to boil. And at 705 degrees and 3,200 PSI, it becomes supercritical water, where it's not really water and it's not really steam, but whatever it is, it dissolves things like crazy. So now it's dissolving the granite above and the mantle below, and it's mixing together, and it's making stuff like limestone and chalk and quartz and salts and, cementing elements and cementing things. And when limestone forms, it releases a particle of carbon dioxide. And there's 60,000 times more limestone on Earth than carbon dioxide in the atmosphere. And Walt Brown asked Bob Dietz, he's the guy who coined the term seafloor spreading. He asked him, where'd all this limestone come from? And Bob says, beats the blank out of me. And so what's happening, the carbon dioxide is just getting recycled in these subterranean chambers. It's not getting into our atmosphere. That's where we get a lot of this limestone. And then it's going to precipitate. So you got all this stuff at the bottom of these subterranean chambers. And then it's getting weaker and weaker and hotter, and eventually it explodes or it erupts. And Walt Brown says there's 372,000 PSI on that water. 372,000. Can you imagine how much force that is going to be released when it gets to atmospheric pressure at 14.7? It's just going to erupt with tremendous force, and I believe that's what happened in the 600th year of Noah's life, the second month, the 17th day of the month, the same day where all the fountains of the great deep broken up. And the crust of the earth cracked. And that crack went in two directions all the way around the earth and came together again like the seam on the baseball. Okay, and that's how it could rain for 40 days and 40 nights. And people say, well, if that happened, wouldn't it leave a mark? And it's like, yeah, it did. It's the mid-oceanic ridge. That's the mountain range that goes through the bottom of every ocean, and it's made by stretching it in two directions. See, compression cracks are like marble cake. They get pushed together. Tension cracks are straight lines. See, rock is really strong compression-wise, but tension-wise, it's just going to break. It's going to, the weakest point is just going to be a straight line break. And if you zoom in on the mid-oceanic ridge, it's got horizontal and vertical cracks. So it's being stretched in two directions. Okay. and then now you got two 60-mile cliffs that are eroding, and they're getting wider and wider and wider. And pretty soon there's nothing pushing down on the Atlantic Ocean. And so now that mid-Atlantic ridge bulges. Okay. That's how the ridge formed. It bulges. And so now it's higher there in the continents, which are on supercritical water, which is 38 to 50 times more slipperier than water or ice. It's just think of it as a big air hockey table. They start sliding. North America and South America sliding to the east, and Africa and Europe sliding to the west, and they keep going until they meet resistance, and then they buckle up to form the mountains. Okay, and this is what it's going to come. So you got that compression mark. That's compression, and this is the Gunnison Canyon. Black Canyon of the Gunnison River, something like that. You look at that, and for scale, those are 15-foot trees on the other side. What force is going to crush that granite to make those compression things? Okay, and I'm suggesting to you that it's the hydroplate, and when it stopped, make resistance, it just kept on going, and it crushed it. And that's exactly what's at the bottom of Grand Canyon, the inner gorge. The Vishnu schist has the same type of pattern there. Okay, so now it's shifting, it's buckling, it's coming. This is the compression phase of the hydroplate theory. Okay, and the mountains are rising up. The basement rock is getting crushed. It's bending up, but that stuff on top is still sliding. And so that's how you get slanted layers underneath flat layers. The flat layers just kept on going and beveled them off. And then this quartzite got formed out of sandstone, I believe, under pressure. And that big mud went by and it lifted it up into that softer sedimentary rock. That's how you explain that rock going from down there to 5 to 10 tons to up there into sedimentary rock. Okay, and then how did the lakes get a mile above the sea level? Well, the Colorado Plateau had to rise up. Okay, so now mountains are a big mass on a small base. Big mass, they're sinking in. And so the magma, which got formed during that compression event, is squirting out to the side. It can't go down, it squirts out to the side. And then and when there's too much pressure, it block faults it up. So the plateaus were block faulted up. So the mechanism for the plateau rising, it's not a mystery anymore. The mechanism is hydraulics, and the force is gravity. Those mountains sunk down and forced the plateaus up. And then some of the lava gets squirted to the top. And then when Grand Lake breaches and the great denudation is coming by, it doesn't wash away the lava, it washes around it. That's how we got Red Butte. Yeah. 1,000 feet of sediment, Mesozoic rock capped with lava. And there's something that, they look real similar. This is Red Butte. This is Cedar Mountain. It looks like a butte to me. They're both the same height, the same flat top. It should be called Cedar Butte. And you can see this from Desert View where that tower is. And Russ Miller was saying how this is the most important geologic feature here. It shows what was on top of the Kaibab limestone before the Grand Canyon could get cut. And then when you look at the canyon or the tower, there's the window that points to that has a blanket in front of it. I wish I would have took a picture. I'm going to try and find a picture of that. But that's a pretty good analogy of how the stuff that points to a creation perspective is being hidden, being swept under the rug or being hidden by the rug, literally. Okay, and this is that fun topographic map. This is Red Butte, 7,300 feet. This is Cedar Mountain, 7,000 feet. And so, yeah, and there they are. If you go into, this is Google Maps. If you look at the Grand Canyon, there's a dark spot. That's Red Butte. As you drive up from Phoenix, you're going to see it on your right. And then when you go to the Desert View, where the eastern part of Grand Canyon, where that tower is, you're going to see Cedar Mountain. And then you can see that as you drive up to, and then on the right, that's how you drive up to Page. And we were driving up to Page one time. They mentioned Echo Cliffs. And I said, are we going to see Vermilion Cliffs before it gets dark? And we did. Okay, so those are, again, Red Butte and Cedar Mountain. Okay, and then just for fun, this is, how the mountains sunk down, and just to clue you in, just to tease the hydroplate here. The mountains sunk down and the plateaus rose up. Well, guess what? When the mid-oceanic ridge was rising up, something had to sink in, and that's the Pacific Ocean. That's where we get the Ring of Fire. That's why the Pacific Ocean is so much different than the rest of the oceans. That's why the trenches are there. Mariana Trench, that's a mile deeper than Everest is high. You got all those table mounts and sea mounts in the Pacific Ocean, all that volcanic activity. And there was even Zealandia. That's the 8th continent, got sucked down. And Walt Brown predicted you're going to find granite in the Pacific, and he was right. And then, oh yeah, this is another teaser for the next one. You got this frozen mammoth that they found standing up near the Arctic Circle. How does that happen? Well, some of the stuff from the fountains of the Great Deep were shooting up with such tremendous force, it got out of our atmosphere and went up, and it got super cold out there in space. When I was flying to Arizona, we were at 32,000 feet. It's minus 48 degrees or minus 42 degrees outside. Well, just think if you went up, a mile, 60,000 or 100,000 feet, how cold it would be. And then gravity grabbed that muddy hail and buried the mammoths. It flash froze them. Okay, and then some of the stuff was going up with such tremendous force that it escaped not only our atmosphere but our gravitational pull. And they find that's dirty snowballs flying around the solar system. That's coming from Earth. The comets, the asteroids, the trans-Neptune objects came from Earth. And the NASA discoveries are validating that. Walt Brown predicted we'd find rounded boulders in comets and asteroids, and that's what they found in Comet 67P. They call them dinosaur eggs. And then they also explains how this major mystery, how two objects each the size of skyscrapers could collide without blowing each other to smithereens. It's especially puzzling in a region of the solar system where gravitational forces would normally involve collision speeds of 4,500 miles an hour. But if they're coming from the same space, same place, same force, same vector, they can come together gradually. And so everything is pointing to the hydroplate. And I encourage you to watch this. This is going to be July 19th. Pastor Kevin Lee and I are going to be talking about it. And Pastor Lee, he stood face to face with the NASA scientist and predicted what they'd find in a comet and also what would they'd find in an asteroid. So I encourage you to put that on your calendar, July 19th. That's a Saturday, and that's going to be a lot of fun. And if you want more information on the hydroplate theory, here's some good sources. Because right now, it's so exciting to be alive. There's more evidence against the Big Bang and evolution than ever before. And this information is more easily accessible than ever before. And it's broken into bite-sized pieces like never before, so the common person can understand it. And that's what all these websites are. You can get a minute or two videos, 5-minute videos. But if you're interested in the hydroplate, I've got a hydroplate on playlist on mine. Brian Nickel does an excellent job, so you can visualize it and very understandable. A lot of the slides that you saw tonight were from his videos, so thank you so much to him. And then what colored in the details for me. I mean, I heard a Kent Hovind video, Age of the Earth, that connected the dots. Fossils are a sign of a flood, not millions of years, and evolution's based on lies. That connected the dots. And then when I listened to Walt Brown Week on Real Science Radio, rsr.org, it colored in the details. I've never seen this Earth the same or the solar system the same. And all these new discoveries, Bob Enyar's has these things, Walt Brown was here. And they have a saying that all scientists work for Walt Brown. And now even AI was working for Walt Brown before it got reprogrammed. But you can see that talk on my YouTube channel. And so with that, we'll do a quick review. We covered a lot of stuff. Let's just quick review. Okay, the key to Grand Canyon is there's a plateau. That's the key. There's two huge lakes on a plateau.
Brian, and before you continue, I just wanted to let you know, take your time with the quick review. I've been drinking a lot of water, brother. It's hot. I'm going to run to the restroom real quick.
All right. Okay, no problem. Yeah. Okay. Yeah. So on this big plateau, this a mile in there, you got two huge lakes. Tremendous potential energy, twice the size of Lake Michigan, about the size of Lake Huron. And again, once that starts going over the top, it's going to cut down. You're going to make that pothole on Echo Cliffs, and then you're going to erode that slot. It's going to go straight down, and then it's going to hit the Kaibab limestone, which is 350 feet thick. And that's why I think it had to have time to get solid. That's why I don't think it happened right after the flood. It could have been maybe 100 years, maybe 200 years. I don't know. But it had to be solid so that the water cutting down, it spread out and made this funnel. Okay, and now the funnel, there's nothing pushing down on the funnel. So again, remember for Grand Canyon, bulging and cracking 3 times. This is the first bulge and crack. There's, 2,000 feet of sediment from Echo Cliffs to Vermilion Cliffs, or Vermilion Cliffs on the left, Echo Cliffs on the right. Oh, and since we got time, do you know why they're called Echo Cliffs? When we were taking that raft ride through Glen Canyon, and the Mo, she's our guide, she said that, and this is pretty close to Lee's Ferry, there was a big high point where John Wesley Powell, somebody like that. Hey, the guy in charge, he had some people go up to this big cliff, climb the big cliff, get on that big high point, and then shoot a rifle or shoot a gun. And then they counted how long it would take to hear the echo. And it was 24 seconds. 24 seconds before they heard that echo. That's why it's called Echo Cliffs on the right there and Vermilion Cliffs on the right. I asked about Vermilion. She didn't know about that. Oh, and then Glen Canyon. She said she was always looking for a guy named Glen, and she never found it. And here it's because Glen is like a peaceful place in a meadow, that type of Glen. And there was a peaceful place on the river. So he called it Glen Canyon. But anyhow, okay, so back to the river. it erodes the stuff off of the Kaibab Plateau, or the Kaibab limestone here, and then it bulges and cracks. And then the water gushes through the crack and cuts Marble Canyon for 61 miles. And then it undercuts Hopi Lake, which is 250 feet higher. And then now you got two huge lakes draining catastrophically, sheet eroding everything. This is the great denudation, everything except Red Butte and Cedar Mountain. Those are evidence of what used to be over tens of thousands of miles. Okay, and so now that's a sheet eroding everything. And now there's no weight pushing down there. So now not only does the Kaibab limestone bulge, but that whole area bulges and makes the Kaibab upwarp. And so that bulges and cracks. That's the second crack, bulging and cracking. And it's now that water that was gushing over the top gushes through that crack, cutting out the Grand Canyon, removing 800 cubic miles. And now there's nothing pushing down on the hard Vishnu schist of the inner gorge. So the basement rock bulges and cracks. And so that's how you get the Grand Canyon, bulging and cracking 3 times. Once in the funnel, once in the Kaibab Plateau or upward, and then once in the inner gorge. Bulging and cracking. There's no way that little river cut that canyon. There's no way, no possible way. So my hope and prayer is that people start pointing this out to the National Park Service. And I think we can do it. You know, they took the signs down for Specimen Ridge where all those petrified trees are. You know, there's no roots there. They didn't grow there. That's where they were deposited after Noah's flood. All right. And so I think if the park system is there to educate us, and they should be, I mean, that's what our tax money should be going through for. It shouldn't be for indoctrination. They should allow multiple competing hypotheses. And I think creation organizations should blaze the trail, set the example. You got your catastrophic plate tectonics model, allow for another perspective. Because it is disturbing if somebody thinks that things could go bad if they even talk about a hydroplate theory. You know, that's not science. That's politics. We need to get back to science and let the science go wherever the evidence leads. Oh, and then, and just let me know when you're back, Donnie. This is kind of a neat side story, but Dr.
I'm back,
Walt,
Brian.
Okay. All right. I'll finish up real quick. Okay. Dr. Walt Brown. There was a geologist, and you might know his name if I said it, but you can see if you want to find out, this is on page 564 of the 9th edition. But there's somebody who's got a different model. I believe it's catastrophic plate tectonics, and him and Walt Brown, they were going to take a trip, spend a week at Grand Canyon, and they each had 3 days to point out what evidence they had for their theory, and they went with a mutual friend. Okay, and so Walt took them, he had them for 3 days, showed them around. And so I took the group to many of the information shown in the book on the 4th day, when it was the other guy's time to turn, to show us the 3 days of his evidence that he promised. He announced that he had none to show us. Unfortunately, our group had adjourned there 3 days earlier. And if you listen to this on Real Science Radio, it sounded like the guy was, even after this, he criticized Walt Brown. And so there's a side story behind all that. But it's interesting to see who wants to step up to the microphone and who runs from the microphone. I think that we should just have an open discussion. That's all that I'm looking for. Okay, so real quickly, we looked at the facts. What's a fact and what's an interpretation? We have to separate the facts from their conclusions, which is not easy at times. Okay, we looked at the questions, a lot of them that can't be answered with a river or millions of years. And we looked at the government's websites and saw how that didn't answer them. And there was even a little bit of deception there. Then we looked at how it actually happened with the hydroplate. And we showed how we jumped into the hydroplate too for how the plateau rose. So with that, again, the key to Grand Canyon is bulging and cracking 3 times, once at the funnel, once at the Kaibab Plateau, and then once in the inner gorge. That's Grand Canyon in a nutshell. And here's some really good resources. Brian Nickel has a DVD, The Origin of Grand Canyon, and I think you can see that on YouTube, but you can get it at rsr.org also. And I've got a YouTube channel, and then also Mike Snavely's got some excellent videos. The Horror of the Flood is really good, and also Grand Canyon, The Puzzle on the Plateau. And that's at missionimperative.org. And then again, this 9th edition is available. You can't get the 8th edition anymore. It's a $30 book, and they're going used for more than that. And they used to be going for 60 or 7. I checked 60 or 70. I checked today, and it's for 45. And but the last one on YouTube went for 270. But you can get the Hydroplate book by going the download, the DVD, rsr.org/HPT. And so then you can check it out there and search stuff. Oh, yeah. Yeah. So there we go. I'll stop sharing. And at the very end, we've got a treat for you as far as a song about the Grand Canyon. So that's the Hydroplate in, boy, yeah, hour and a half. Or no, that's the Grand Canyon. That's one perspective. I think it answers a lot of questions. And I hope that the National Park System puts it on their website so that, and also on the placards, give people another perspective. That's what my hope is. Let people think. Don't make them memorize. Let them think. Give them competing hypotheses and let us think. That's what my goal is.
Brian, excellent job. That was information packed. There was a lot of good information there. And like I said earlier, I'm glad I'm not an evolutionist, and because I'd be forced to now give my opening statement or rebuttal. And what could I say? Uniformitarianism clearly lacks to provide answers to what we see in the geologic column in general, but in the Grand Canyon. Specifically right. This focus. I like the way you put it, Brian. Who's brave enough to step up to the mic? And so the challenge is out there. I'd like to see somebody informed, a critic, a skeptic, somebody who wants to have a professional exchange to reach out, and we'll set something up sometime in the next few months. I would love to have a formal debate on the Grand Canyon. And so what I'll do, Brian, is I've got a few of my own questions that I'd like to get in there. And then we've got several people backstage, so we'll bring them in. And I am familiar with every single one of them. And so we'll have some good discussion. Looks like we got a good mix of creationists and non-creationists backstage. And so a few points that I have, most of them are on the Grand Canyon. So I'll get a couple out of the way based on non-Grand Canyon related issues. I find the rapidly frozen mammoth point to be interesting, and I'd like to interact with that briefly, Brian, because it's an interesting reality that we find this. But from the Hydroplate perspective, then I guess the interpretation of how that happened and when that happened, would you have to say that mammoths are therefore a pre-flood creature?
That's what Walt Brown would predict. He made a prediction that you won't find coal and oil and fossils under the mammoths. And Bob Enyart says make it a standing mammoth because they could get moved around in moving sediment. And so yeah, that's his perspective. They got buried as the fountains of the Great Deep were erupting and got into outer space. He would say they were pre-flood. And the interesting thing about mammoths is they're not woolly; they're hairy. They can't live in the Arctic. They eat too much. They drink too much. They're temperate animals. So the question is, how do you freeze a temperate animal so quickly? And that would be the big hail that we talked about. And then it's like, well, how come it didn't thaw out? And that brings us to the big roll, because the Himalayas, there's nothing in the southern hemisphere that cancels out the Himalayas. So you got a big mass on a spinning object that's going to go to the side. So it's going to take stuff that's on the top and bring it to the side. Therefore, stuff on the side went to the top. And you can see that the 90 East Ridge is 3,000 miles long, perfectly straight, crack in the earth. And that points directly at the Himalayas. And I believe that's because the equator has a bulge there. And as the earth rolled through that bulge, it cracked the 90 East Ridge. So that's my 2 cents on the hydroplate or on the frozen mammoth, but it's worthy of discussing, I guess, and comparing.
Yeah, I think those are some good points and some interesting points. If someone were to push back and say, well, due to their design, the thick fur, but you're saying they're more of a hairy mammoth, but what about their fat deposits, the small ears and tail that would allow for better heat absorption? What if somebody said the majority of their traits suggest that mammoths were built for ice age, cold environments? How would you respond, Brian?
What would they eat?
That
They
was
eat
great.
like they eat like 600 pounds a day. They drink like 50 gallons of water a day. If they're in the ice Arctic, what would they eat? Plus, our nose gets cold in the winter. Our nose inch long. You know, could you imagine a 6 foot long nose?
Yeah, because they would be herbivores, so they'd have to be eating a variety of plants, shrubs, mosses, flowering plants. Are you saying that that would be lacking in
well, if they're Arctic
ice?
animals, yeah, if they're Arctic animals, where would that, you know, if it, what would they drink? That would be the main thing. You know, where would they get the water to drink? Because it would all be ice up in the Arctic.
Well, I guess in a post-flood ice age, wouldn't at the same time because our ice age wouldn't be lasting as long as theirs. So would there be enough water just due to the melting of some of the ice caps or the? I mean, I'm not a mammoth expert, but
yeah, I don't know.
What did mammoths drink?
But they're hairy animals and they don't have an oil gland to make it watertight. You know, it's not fur. That's a misnomer, or it's not, it's not wool.
Because I'm reading, it says that they primarily drank water, 50 to 200 liters per day. They likely drank from lakes, rivers, and other freshwater sources in that cold environment. Well, I just find it interesting because mammoths you'd have to agree, superficially, they do look designed for the cold ecoglacial environment. Because I know there's two different positions, right? Mammoths were flash frozen, but then that means they have to be pre-flood. So like you said, you would have to argue that they were not built or adapted for cold ecoglacial environments. Well, yeah, it is interesting the way that they're, at least with the subcutaneous fat and the thickness of their hair. I think you make some fair points, Brian, but definitely it's an interesting discussion to be had, Brian. Any additional thoughts on that?
Yeah, that's something we could dive into in the hydroplate seminar. I probably shouldn't have brought that up.
No, that's good. It's just an interesting, because yeah, I think there's some fair points on both sides. We've had Mike Ord on. He's given a good presentation on mammoths in the ice age being adapted from an archetype. So I've heard somebody say that they don't need to be flash frozen because they have pretty good preservation of their stomach contents. And so not everything was completely frozen, which means they could have happened during an ice age after the flood, Brian. And any thoughts on that?
Well, what's the first thing you do when you shoot a deer? You gut them, because the heat's going to spoil the meat. And, you know, it's going to, if it just slowly froze from the outside, everything in the middle would be rotten. And yet the sled dogs were eating them and it didn't make them sick.
That's a good point, Brian. Interesting. And this is why these kinds of discussions are important, where you get those from differing viewpoints, let's say CPT perspective, HPT perspective, which we're trying to do. We're trying to get a roundtable discussion.
Yeah.
Okay. Well, I think you made some interesting points there, some fair points. Okay. So the next question I would have, Brian, is it has to do with the dam breach hypothesis.
Yep.
And skeptics, as you're very familiar with, they'll look to the shorelines of various ice age lakes, for example, Lake Missoula. Yep. So that's a common one. And then they'll say, well, there's no evidence for these postulated lakes in the dam breach hypothesis due to the lack of shorelines that we see in other ice age lakes. What would be a good response to that?
Well, the Missoula Lake, that could have been there longer, and keep in mind that Colorado Plateau, as it's rising up, that's very unstable. As it's block fault. Look, oh, did I lose my voice? Am I still
No,
talking?
no, we can hear
I
you
hit
there.
the wire. I didn't know. But as the Colorado Plateau is block faulting up, that's going to change the shoreline constantly. So the shoreline isn't going to be steady, and it's going to be, it's going to be an unstable part of the country. And then also there's there's so much water saturated in the soil that it's just going to gush out with tremendous force, or it's going to gush out like crazy, and it's going to wash out the lake sediments out of the bottom of the lake. And so if those are not lakes, why are they so different than the surrounding areas? When you look at from a satellite, there's an orangish tinge to them. And if they weren't lakes, what caused that? And if they weren't lakes, what caused the fuzzle? What caused that funnel? Vermilion Cliffs and Echo Cliffs, those used to be connected. And if the lake didn't do it, what did?
Yeah, that's a good point. Somebody who would oppose or reject the dam breach hypothesis, they're going to have to put forth an alternative explanation for a lot of these features you're bringing up.
Well, yeah, and that's, and it's easy to throw mud, but let's see a solution. If this theory doesn't work, what theory does? Explain to me how you cut into the hard inner gorge. Explain how come it got deeper instead of wider. If this isn't the right theory, show me one that is. Show us how you get the side canyons without rivers, and show us how that, why is the Marble Canyon so much different than Grand Canyon? Why does a canyon that's going straight south suddenly take a right-hand turn? Why does that happen?
That's a good answer. So the next big objection that I've seen, and I think this is good that we're engaging some of these challenges, because there are many Cretaceous that are kind of on the fence. And I think I'm one of those Cretaceous where I've seen fair points on either side, the various models in the young Earth Cretaceous world. But it is good that if you're in the young Earth Cretaceous camp, then you agree that the uniformitarian explanation has major problems with the origin of the Grand Canyon. Yeah. Now it's about being in the right worldview and viewpoint in general, and now coming up with the best model, right? And that's what we're doing. And so they'll say, well, since lakes nearly always have sediments in their deepest parts, and we don't find bottom sediments where these purported lakes are said to have been, this argues against there ever being lakes there. Brian, what's a good response to that?
It got washed out. There was so much water gushing in from the subsurface that it washed out. And then you look at, the little Grand Canyon, the little Colorado River. That's the bottom of Hopi Lake. And so I would say that the sediment washed out. I mean, you look at Monument Valley, that's sand, and that's the bottom of a lake. And for those who don't think it was a lake, well, how did those mesas, buttes, and spires form then? If this wasn't a draining lake, how did it form? And even goosenecks and Horseshoe Bend and stuff like that, how do those things that are just so weird happen?
Yeah, that's an interesting point. It's good questions. What if somebody looked to the glacial Lake Missoula in Montana, and how that burst at the peak of the Ice Age?
Yeah.
And it said that the water rushed out of the lake at 90 kilometers an hour, but still left a large amount of bottom sediment.
Well,
go ahead.
There might not have been as much. The dirt might not have had as much water in it. It might not have been as saturated. See, it's the water from the side that washed out the sediment. And if it's a glacier, there's a lot of frozen stuff up there, so it's probably not going to flow real easily. And so I would just suggest that that there was, because after the flood, there's going to be a whole lot more water in the subterranean. It's saturating the earth.
Right.
So there's going to be more water to drain there. I think that's why those cliff dwellers left. The water ran out. But you brought up the Missoula flood, and that's an important lesson for the blind chancers. Because J. Harlan Brents, he said that the scablands were formed by a catastrophic flood. a glacial lake flood. And he got ridiculed and rejected because they were only allowed to think in uniformitarian ideas. They were boxed in. That's all that they could think about. That's all they were taught. So they ridiculed him. You're not doing what the consensus says. Well, the consensus has been wrong a lot. And then when they got satellite images, it's like, oh my, you were right. This was a flood. And they gave him some award when he was in the 90s. And so sometimes science progresses one funeral at a time, and hopefully that's not the case here. But yeah, so we can learn something from that. Let's just put multiple theories on the table and just honestly talk about the strengths and weaknesses without any egos involved or money or prestige. Let's just discuss it. That's how science should be. That's what Dr. Thomas Chamberlain said over 100 years ago. Always have multiple competing hypotheses so people can think. Otherwise, they just memorize and conform. And I think creationists should lead the example there. Allow for the hydroplate.
Well said. Multiple working hypotheses, multiple competing hypotheses. This is how we best come to the truth. And I find it interesting that even those in the uniformitarian or actualist camp, there are many who look to a catastrophic explanation for the origin of the Grand Canyon now as well. They'll look to massive floods from a glacial outburst or overflowing lakes in order to rapidly carve the canyon, because they're recognizing a lot of these same challenges as well. Lack of erosion between the layers, the canyon's path itself. So
well, even all the fossils like Dreadnoughtus or those big dinosaurs that they got somehow just fortunately got swept away and landed in some quicksand. They can have millions of floods, but they don't have a worldwide flood. And so they're getting closer. Just keep looking.
Well, I find it interesting. There's a critic here, John Rapp. And so he says, real geology for hundreds of years has known how the Grand Canyon was formed and carved. But going back to what I just said, okay, if that's the case, then why are there many in the uniformitarian camp that are recognizing these major challenges to the common understanding of, I guess, the conventional understanding of how the Grand Canyon was formed? And now they're looking to catastrophic events like massive floods or periods of rapid erosion that may have been evolved. So even they're in many ways flabbergasted, aren't they, Brian?
Well, I would suggest that John Rapp tell the National Park Service how it happened, because the National Park Service doesn't know. So he can help them, show them how it happened.
Yeah, they need to be biblical creationists. And then right there's a good starting point. And then from there, you can come to the ultimate truth. So Brian, my brother, next objection or challenge.
Oh, wait, let's go back to that. Real geologist. Okay, who's a real geologist? Is that somebody
exactly what qualifies a real geologist?
Is that somebody with a blind chance perspective of the past that thinks we just got here by chance? I mean, do you really think your house got put together by chance? I mean, that's absurd. How much more absurd to think our bodies got put together by chance? And yet that's the problem with our government education system. They only allow one perspective. And it's like if I had a chest of gold and I said, you can have all the grant money and time in the world to find this chest of gold, but you can only look in your house or in your business building. And I put it out on your driveway. You'll never find it because you can't look out there. And everything is pointing to a creator, but everybody's afraid to go there because they might lose their job. And that's not science. We gotta let the evidence go. We gotta have the freedom to think. And that's not happening. They gotta think that we just got here by chance. Hydrogen and helium just turn into people just by chance. And I don't buy that. That takes way more faith than a creator does.
Amen. Apparently a real science is somebody who believes they're related to a banana plant, that everything descends back to a single common ancestor a billion plus years ago.
Right. And again, that's
nothing but recycled stardust. That's a real scientist, apparently.
That's not science, because it's not observation and testing. And that's what we need to clean up too, is we need to deal in science, not imagination or belief systems.
Brian, in order to be qualified as a real scientist, you have to go into the interview and there's a checklist on a piece of paper. Do you believe you're nothing but recycled stardust? Yes, sir. Check mark. Do you believe you're related to a strawberry? Yes, sir. Check mark. Do you believe everything came from nothing? Now you're a real scientist. But if you believe God created, apparently you're no longer qualified to be a real scientist. It would be like, and you made a good point there, if I were to show someone a sophisticated computer, these computers that
Right.
we're on, or your MacBook, and
Right.
say, okay, how is this designed? How is this made? But you can only look to the computer itself. You can't look to man. You can't look to anything external to the computer. You're never going to figure it out then. You're never going to come to the truth.
Exactly. Good analogy. That's perfect. Yep. We need the freedom to think. And most of science, most of the fields of science were started by creationists. You know, it's
That's right. That's a good point.
And yet they're getting kicked to the curb. It's really a shame what's happening in science. It's all consensus and a lot of grant money. Now, who was it? Eisenhower. He warned about this. When you start paying for science, you're going to get the science you pay for. And then you're going to get a technological elite that's controlling public policy. And we're seeing this. We're seeing that with COVID. We're seeing that with climate, and we're seeing that with evolution and the Big Bang. Go into cosmologystatement.org and see how all the problems with cosmology, and they say, well, you know, all the people who fund cosmology are big bangers, so they won't allow another view. And that's we really need to have to clean up science. We need to get the money out of it. We need to give people the freedom to think, because it's not happening right now.
The freedom to think, very important.
Yeah. A diversity of thought. You know, if diversity is our strength, let creationists in the science room.
So the next major challenge that I have heard, Brian, I'd be curious to see how you address it. They'll argue that there should be a large delta at the mouth of the canyon where the current slowed. So apparently the delta is not found at the mouth of the Grand Canyon, and therefore the dam breach hypothesis should be rejected. Brian, any thoughts on that?
No, that should reject the river carve the canyon, because the river carved the canyon. There should be a huge delta there. But if there was the big dam that broke, that's going to wash that delta out into the Gulf of California. And it's also going to have a surge deposit all the way down on either side of the Colorado River, which is what they find. I forget who it was, but they said that, you know, that's a surge deposit, something that was rapid and powerful in once. And I think that's the dam. That's the breaching dam. And then Walt Brown says he thinks that the sand dunes, is it the Imperial Sand Dunes? If they do isotope dating on that, they'll find that they came from the Grand Canyon. And so that's where part of the delta could be, is in those sand dunes. But that little delta proves that river didn't cut it, because that's where it should be if the river cut it, and it didn't.
How could we address this challenge, this question? How is the Kaibab Plateau cut through at a present day altitude of about 2,500 meters and not at its lowest point of roughly 1,700 meters, where it should have been the easiest?
Well, that's because that's where it cracked. It cracked in the middle. It bulged and it cracked, so it didn't flow where it should have flowed. You know, bulging and cracking. As it bulged up, it cracked at that point, and then the water gushed through and cut out the Grand Canyon. Because you're right, it should have flowed either to the north or to the south around the Kaibab Plateau, but that didn't. So why didn't it? That's a tough one for a blind chancer.
Yeah, the blind chancers, they've got a lot of difficulties. They need to give up on that idea. Brian, can a dam breach carve the long side canyons? The
long side canyons?
Yeah.
I would say no. I would say that the side canyons were carved with the because it cut below the water table. You know, maybe it could, but I like to think of it as the crack went below the river's cutting below the water table. So all those saturated sediments, all the water there is gushing is coming into the canyon, and it's bringing with it the sediments with it. Or it could be, you know, just taking the sediments underneath and the top collapses down into it. That's another option too. But there's something, you know, the river if the river cut the canyon, what cut the side canyons? And I think it needed some source of water, and I think it's the water table that drained fast.
That's a good answer. Well, what are your thoughts on this comment from Sophia? We've had several comments, and then I'll start bringing people in for some live Q&A. And Sophia says it's called denudation It's called denudation. It formed due to tectonic uplift. I'm trying to figure out when this was said during your presentation, but comments were kind of coming in as you were talking. It formed due to tectonic uplift of the Colorado Plateau, followed by gradual erosion. Is there anything there you'd want to speak to?
Well, if it was gradual erosion, you'd have one slot. You can't move that much dirt gradually. It had to be catastrophic. I mean, this is 1,000 feet of Mesozoic sediment that just got thrown away. I mean, how do you gradually erode 1,000 feet of sediment? There should be a bunch of little valleys there if that's the case, but it's all gone. And you can look at Red Butte and you can look at Cedar Mountain. That's what used to be all over that area for tens of thousands of miles, and it's gone. You can't do it gradually. And what was the force for the tectonic lift up? Where did that come from? What's the mechanism? What's the energy to raise that plateau? And so it's but no, that you could not do the great denudation gradually, in my opinion.
It's a good answer. I appreciate you interacting with that, Brian. And so, okay, we got several people backstage, and so I'd like to get some live interaction. Brian, you did an excellent job answering my questions and the challenges that I put together for you as a way to keep this comprehensive, as I know people were looking for a debate tonight. And so I did want to put forth the common objections just to see how you engage them, Brian. So I appreciate that. I think that's a good teaser into the kind of rigorous discussion we are going to have next month, my brother, in our HPT seminar. Okay, let's start bringing some people in. We got Brian from Apologetics 101, who takes the creationist position. We've got Andrew Cumming, our resident evolutionist, so he holds to the common descent position.
Welcome aboard, guys.
We got Scriptures and Stones, who holds to the old earth creation position. And we've got Jungle Jargon, a fellow young earth creationist. So we got a good,
great,
good mix here.
Thanks for taking time on a Saturday. Appreciate that, guys.
It's a Saturday night showdown.
Praise
and
Lord.
So, gentlemen, we want some good free-flowing and organic interaction, questions and engagement on what was said in the presentation. Of course, questions and in a question mark. We're not looking for 5 to 10 minute responses or opening statements. We do want some free flowing back and forth in order that we can really utilize the next 30 minutes. I think we'll do about 30 minutes here of live call-ins. And so, Brian from Apologetics 101, you have been very patient, my brother. You were the first one here backstage. And so, to be fair, let's start with you. Brian, tell us, how are you doing tonight? What did you think of Brian's comprehensive presentation answering the question, what is the true origin of the Grand Canyon? And what question or comment did you have for Brian?
Hey, can you hear me okay?
Yes.
Yes.
Loud and clear.
Okay, awesome. Okay, as Donnie mentioned,
Actually,
I'm
Brian,
a YEC, Young Earth Creationist.
Actually, Brian, before you continue, there is kind of a large echo. Is your audio coming through your external mic? Did you double check that in the settings option?
Well, it might be because I got my sound coming through my speakers.
Okay.
I could try.
It's okay. We can deal with it. It's not a huge deal if it's something that
sure,
some people
I
in the
got
chat are
earphones
saying it's a bit echoey.
Okay, I got earphones I can reconnect if you want me to do it that way. It works too. I might have to do the settings on the thing. I don't know.
It's better now.
Yeah, it's sounding a little bit better, Brian. So feel free I should say, Brian, meet Brian. So we got two Brians in the same show. We're making history.
A pair of Brian.
Feel free to ask Brian.
Donnie stole my joke. Donnie stole my joke.
I had a feeling you were going to say,
hey, Brian, I'm Brian.